All right. So Hardhat, much like Foundry that we used in our last video, is basically an Ethereum development framework. Right now, one of the things that I like about Hardhat the most is that it is like in Hardhat you write everything using JavaScript or basic JavaScript. So you don't have to. You can either use JavaScript or TypeScript, but I think JavaScript is one of the most popular languages, and all you need is Node installed in your system. Like so, I think it works just fine for all Windows or Mac or Linux system. All you need is Node.js, and it works, right? So yeah, as you can see, it's basically an Ethereum development framework, and just like any other, popular frameworks, it comes with all the tools and gadgets to help you test, help you deploy, help you interact with your contract, right? And I think a lot of people. I think Hardhat is actually one of the most popular, frameworks that people use to build stuff. And like I said, it has a lot of cool toolkit. Like it has a comprehensive toolkit that can handle everything: compilation, testing, deployment, everything. And since Injective is EVM compatible, all of these toolings just works. I mean that's actually one of the huge advantage of Injective's architecture. We don't have to write a whole new set of tools or anything. Like since the whole thing is EVM compatible or built on top of EVM, all the mature battle tested tools that Ethereum developers have been using, it works perfectly on Injective too. So and the thing is, like, we can configure Hardhat to point to Injective's RPC endpoint, and we can basically, use that to deploy our contract and interact with it and everything. So in our project, we'll set up a bunch of contracts and we'll set up a bunch of scripts and scripts which includes one for deploying, one for funding the contract, one for calling the uh, place order function and all those kind of things. So for all that, we'll create script, and also we'll create the contracts that we will actually deploy. Now, yeah, so that's pretty much the basics. Like we can just go ahead and get started with hard hat. But before that, like since we are going to work on Injective, I'm pretty sure you guys already know this. We'll be interacting with the Injective testnet. So make sure that you have the Injective testnet details added to your MetaMask account so that you can keep track of all the faucet tokens and stuff. Like I have already added it, but if you want to, you can just go, I think, network information. Yeah, just go to the Injective docs, network information. You can, yeah, go to this. Yeah, there you go. So there is the main net and this is the test net. So you can just add all these details. Okay, so you can just go to MetaMask, click this networks, add custom network, and add all these details. So I've added all of them. So it's pretty cool. So yeah, that's it. And once you have these things, what you have to do is just go to the testnet faucet. There are a couple of faucets like Injective testnet faucets available. There is this one where you just have to paste the address. Just copy this address and paste it here, and prove that you are not a robot. And oh wow, it is actually giving me a test. What is this? Okay, okay, whatever. So yeah, just click on request tokens. Oh, okay. So I've already, yeah, of course. Now there is a much more generous token also, which is called. You can just go to Injective Google Google Faucet. This is a way more generous faucet, which gives like 10 testnet tokens. You can also check it out. You just have to, okay. So for this, you have to get the Injective address. Okay, just place this and you will get your Injective address. So copy this and you have to paste it here. I got like 10 Injective tokens. So yeah, right. So yeah, I already have these tokens, but yeah, it is much more generous because we get 10 tokens. So yeah, make sure you have the tokens, and then we can just go ahead and set up our project. So let me just resize the whole thing. Okay, this is better. Yeah, save it, open a new folder, integrated terminal. I'll just create a new folder and I'll just call it market trading bot. Yeah, let me just cd into it. And yeah, to set up a hard hat project, like I said, all you need is you need to install Node.js. So just go to the Node.js website. It's pretty simple, like for, and it works across platforms, right? You just have to download it, like if you are using whatever, like Linux, Windows, Macs, whatever, Mac OS, whatever, you can just install it. And yeah, then you can go ahead and install hard hat. So once you have node in your system, just go node minus v. I think it's better to use a version greater than 22.10, like version above 22. It can be the latest. I think latest is around 24, but yeah, use something that's about 22 or above, right? Don't use 20 and stuff. Okay, so yeah, then what you have to do is just type in npx hard hat init. Okay, so this will initialize hard hat. So I'll just go for the older version. This is the path, and yeah, so Mocha with ether.js. So ether.js is a library that helps us interact with the RPC nodes and stuff. So we'll just set up a basic JavaScript project using Mocha and ethers.js. Now Mocha is a testing framework. We won't be using a testing framework for this one, but yeah, I mean, you can just select that. Uh, and the best part is it will just install all these different libraries, right? Like a lot of these, we won't be using all of them, like chai and yeah, ethers we will. But yeah, we will be using some of these libraries, but yeah, it will just install everything, so it's fine. And if you go to the folder, you can see that we have a basic project structure setup. You have the contracts, you have ignition. I'll tell you what it is, but you have the test. But I think, yeah, I mean, for this, since we are keeping it simple, you can just delete the test and ignition. We'll just use contracts, and we'll also create another folder called scripts where we will write all the scripts. Yeah, so that's basically it. And one another really important thing that you have to look at is the hard hat config.js. So as the name sounds, this is the command center or the control panel of the project, right? So for any configuration that is in your project, you need this, like for any and all configurations that you have to set up, like whether it is adding setting up the test networks, setting up the compiler version, whatever, you do this in the config.js. Like we will do it, like I'll show you how to do it once the whole thing is installed. So yeah, so this is like we have already set up our basic project structure. Now once the whole npm packages are installed, we'll just go ahead and configure our projects and start writing our contract. So yeah, let's go. All right. So now that we have installed all our packages and our project is set with all the different folders and stuff, let's just go ahead and start writing our contracts. Now, before that, I think we can just go ahead and delete the ignition and test, because we won't be needing those. I mean, we'll focus on the contract. Okay. Now we would need a script folder called scripts. And what else? Yeah, so scripts and contracts. Yeah, we can also remove this contract. And yeah, so before we get started, I guess we can just you know configure a couple. I think we let me just check. There is one. Okay, so the thing is, we need to install one more package, which is the .env. So npm install .env. So this package basically, as you guys probably know, like it helps us retrieve the environment variable. So we need this because we are going to store a couple of things in our environment variable. So let me just go ahead and create a .env file, right? So a couple of things, like the first thing that I need here is the injective uh, testnet RPC. right? RPC URL. So this, like, you need this in order to interact with the node and, deploy your contract and query it or interact with it and everything. So you can just go to the Injective doc. Injective doc. Yeah. So you can just go to the Injective doc, and there is the Injective mainnet and testnet. Details like, EVM developers, network information and stuff. And yeah, so there you can just, you know copy this, and you can just paste it there. So yeah, so this is going to be the RPC URL via which we will be deploying our contract and interacting with it. So yeah, so once that is set, I think .env is also installed. We also need something else, which is the private key. Private key. Now you know how to get the private key. I mean, it's pretty straightforward. Just go to MetaMask, open it up. Okay. Go to account details, private key, again password, and just hold this. Right. So let me just do that off screen. Okay. So yeah, I got my private key. Let me just store it. Give me a second. All right. So yeah, so I have my private key set. So those are the two variables that we need. Now, once we have that variable, we can just go ahead and set up our config, like Hardhat config. So here we will specify the network details and everything, like the accounts that we are going to use and the network details and all those kind of things. So this will basically help us. Yeah, I mean, this, like, we will be using the injective testnet, so we just have to configure it so that every time we deploy or interact, hard hat knows which network are we talking about, which accounts are we talking about, and everything. So you don't have to give everything explicitly. So first, let me just require uh, .env config, and then we'll just say networks and injective testnet, and you'll just give the URL. So for the URL, we can just go process.env dot injective, like the same environment variable that we have given, RPC URL, right? So that is the URL, and then we have to give the accounts. So accounts, the thing is, there. I mean, you can directly give it like this. You can just put process dot env dot yeah, private key. So yeah, just put the comma there. Okay, and then chain ID. So this is 1439. Yeah, 1439, and gas price. Yeah, and gas. Yeah. Okay. So this is basically our whole configuration. Like, we've given the a couple of stuff that we like, we have set it up so that we don't have to explicitly provide it when we are trying to deploy the contract or interact with it. So once that is set, let's just go ahead with our contract. Now, what you have to understand is, yeah, about our contract. Like, the whole idea is pretty simple. Like, that our contract will interact with the exchange, precompile, and it from there it can just place orders, spot orders, cancel them, and all those things, right? So the thing is, like, I already mentioned that our contract address, it won't directly trade. So what happens is, we will deploy the contract, and we will fund this contract with some injective tokens, like testnet injective tokens, and then we will select a pair. Like so, if you go to the Injective Explorer, I think I already showed you this. Like if you go to the Injective Explorer, yeah, Injective Explorer. Okay, so here you can see that now this is the testnet explorer. Okay, like injective testnet explorer, you can go to the trading markets. You can see that there are a lot of these pairs, right? So if you want to trade on, let's say, what is a good one? Maybe injective. These are all funny ones. I need some, maybe injective or USDT or something like that. Just take 50. Wow, nobody's trading injective. Oh, okay. Yeah. So yeah, okay. See, this is a spot, like a lot of derivatives, and this is the first spot, right? Yeah. So this has a market ID, right? So we can give the market ID to our contract, and it will just place our order and everything based on the quantity and the amount that we are giving. So like I said, so our contract won't be directly trading with. Or directly doing the trade. What happens is it will automatically create a sub account, and like we have to, once we deploy the contract and fund our contract with some funds, then we have to deposit some funds into the trading account, okay, or the sub account, and from there it can do the trading, right? So that is the general logic of our contract, and we will also put in some safety measures like pausing the trade and all those kind of things, and a lot of methods to actually query information, like the details or the status of the contract. So yeah, so that is the general thing. Now one additional thing that you have to understand is, so in order for our contract to interact with the precompile, the thing is it cannot just do it directly just because it knows the address. Okay, like I already told you that these precompiles always exist in a particular address, right? Like you can just go and this is the address, but just because it knows the address doesn't mean that it can just go ahead and call its function. Your contract still needs to know the kind of functions that are there in the precompile, the name of the functions, the parameters that it takes, the kind of output that it gives. So all those kind of things needs to be there for the contract in order for it to interact with it. So what happens is we need to get the interface for the precompile. Okay, so interface, as you know, is a type of contract where it defines the entire functions and everything in a contract, right? It won't have the logical, it won't, I mean, it declares the whole thing. It won't define its logic. It will just declare the functions and the parameters and the type and everything. So that when a contract uses the interface and it has the address, it knows that the contract in this particular address has these set of functions that takes in these set of parameters and that gives out these set of outputs. So, like if you go down, I think. Yeah. So go to the solidity contracts and you can actually see, like this is the injective example. Um, so if you go to source, you can see that there are three major ones. Like you can see the Cosmos types, the exchange dot sol, and the exchange types. So exchange types declares a lot of messaging types that are there. Right, you can see user defined exchange method that can be approved. This matches the message type defined in the exchange. Okay, so these are something that is used in the interface. I mean, they could do it in like one big contract, but that is like not professional. So then you have the exchange.solve, which is basically the definition of all the functions that are there in the precompile. You can see that it's just function declarations with the parameters and the return types and stuff, and also like the comments on what it does, right? And then there is one more, which is the Cosmos types, which also declares a couple of structs and stuff that is used in the precompile. So the contract needs these information in order to interact with the precompile. It's not just going in blind. It is using these interfaces to actually interact with the contract. I mean, this is the interface. Like the exchange.sol is the interface, and the other two, like I said, it's like modularized version. So the types and the Cosmos types are just modularized, two separate folders to keep those information. So we need this in our uh, we basically need this in our contract, right? We need to use those things in our contract. So for that, like I've created, like I'll just copy, like I already have the copy of these things. So I'll show you. I'll just again just for just so you guys know, there is the exchange dot solve. Okay, this is basically the general interface that tells you what are the functions there. Then there is the Cosmos types.sol, and similarly there is something called exchange types exchange types.sol. Okay, so these three are like interface, like it includes information regarding what all are there, like the functions that are there, the data type it uses and stuff. Now I already have it, like this code will be available in git, so you can just directly copy it from the official repo or here, like either way is fine. So this is exchange.sol. First then exchange types and Cosmos types. One second. Okay, so these three things are required in our contract. Like I mean, we'll be just importing the exchange.sol, but the exchange.sol actually requires these two things. Oh, okay, Cosmos types. Um, I think, yeah. Let me just, so yeah. Once these contracts are there, like we will be importing it to our major like simple trading bot contract, and then we will use these. Then we will just attach our address, like the precompile address, and then use all these functions so that our contract knows what we are dealing with. Okay, the kind of functions and the kind of data that goes into these functions. So we know, or our contract can know all these things. That's why we are using these interfaces. So yeah. Sorry. So yeah, just to see if there is any errors, like I just copied the same thing. Just to quickly compile, what you can do is just type in npx hardhat compile. This will just quickly compile all the contracts. You can see three contracts and all the artifacts are created. I mean, nothing major. We're just checking if there is any errors, syntax or anything. But yeah, I mean, this is like Visual Studio being crazy. But yeah, I don't think there are any errors. So let's just go ahead and create our, simple trading bot contract using all these interfaces and everything. All right. Yeah. All right. So yeah, we have our precompiles and everything set. So let's just go ahead and create our simple trading board contract, which will use all the interface and the precompile to, access all the cool functions and place our orders and stuff, right? But everything will be under the owner's control. So yeah, it's pretty cool. So let's just go ahead and create this thing. So I'll just say simple trading bot.sol. So this is the trading bot, and yeah. Yeah, let's just start with the pragma. Okay, so I'll just put the MIT license, and the version is greater than 0.8.0. Right? You can put, I mean, something much more closer. It's fine. You just say 20. I mean, it's fine. I think what. So make sure that it's the same version. Yeah, it's 28, so it's fine. Make sure the version doesn't conflict. There is no conflict of version in like in your contract and in the config.js. So I mean, yeah, yeah, get it now. Okay, simple trading bot. All right. So yeah, now let's just go ahead and create contract simple trading bot. So first we will just set our star of the show, which is like constant exchange precompile, right? Precompile. So this is basically the address that we are going to use. Now you guys know the address. It's like 0x65. So we'll just copy this. Oh, I almost forgot. Like we need to import our, you know, yeah, import dot slash exchange. We just need to import the exchange dot sol. So yeah, so that we can use it. Right, so it is there, and then like you can see, like if you go to exchange.sol, it's this is the interface, right? So we are going to use that right away. So we are going to say I exchange module. You can see it picks up public immutable, which means that we get to put the value into this once. Okay, like we can initialize the value once. Usually in the constructor, we'll get to initialize this value once. Now we need a couple of constants, which will tell the type of order that we are going to put. So it's like string public constant order type by, which is like by, and string public constant order type cell, which is going to be cell, right? So yeah, so we need these two constants just as a way to identify the order type. Then yeah, then a couple of address public owner. Then we will have a boolean value, which will say the state of the trade. We'll just say trade paused, which means which will, if it is true, the trade is paused. If it's false, the trade is not paused, it's still going. So it's like a safety switch. So we'll also say for our sub account, we will need a sub account ID, which yeah, I'll show you. Like it is automatically created, and we also need an event. Like the thing is, when we place an order, we need to share certain things, including the order hash, which is like the ID for the order. So we'll create an event called spot order placed, right? And it will have string indexed market ID, which is like the thing that I showed you. So bool is by, right, and un 256, I mean 256 price, un 256 quantity, what else? String. Yeah, so this is the order hash. Like we need this, we need to get this in our uh, in order to cancel the order or whatever, we need the order hash. So yeah, un 256 and maybe the timestamp, yeah, just so we know. uh, yeah, so yeah, so that is the event, and we will also add a few modifier, right? One of them is only owner. So the only owner, as you know, it requires that the message dot sender uh, sender should be equal to the owner, right? Else we can say caller is not the owner, right? Yeah, and this one. Okay. So the next is we'll have another modifier which when not paused. So as it sounds, it just check whether the trading is ongoing or not based on the flag, like the trading post flag, right? So yeah, trading paused. If it is true, then we'll just say trading is paused. Come back some other time, right? So yeah, okay. Then uh, modifier. So the next modifier is basically, yeah, a valid amount. So we need to have be vigilant regarding the amount that we sent. It shouldn't be zero because it doesn't make any sense. So we'll just say that require amount greater than zero. Amount must be greater than zero. And of course, to check the amount, we have to give amount here, which is a uint 256, right? Yeah. So that is there. So yeah, so we have the modifiers set up. Now let's just start with our constructor. So within the constructor, it's pretty simple. We can give, so the thing is, uh, yeah. For creating the sub accounts, we can actually provide the sub account nouns. Like by default, it is one. Like we can suppose you want to create other sub accounts. Also, you can just put nouns there, and it will just automatically create a sub account with that nouns. So it's pretty neat. So we'll put that in our constructor. We'll just say, okay, use this nouns to create the sub account, right? So yeah, we will just use this, and yeah, owner equals message dot sender, right? Exchange equals, so we'll just put the exchange module. So exchange is going to be, you know, yeah, it's basically the instance of the interface. So we are going to attach it to our address. So yeah, and trading cost is false, right? So it's going to be false. Now, okay, to create, okay, so now what we need to do is we need to set our sub account ID, right? So for that, what we need to do is, like, we need a couple of things. First, we need a separate function to actually create it, and then within that function we also need, we can do it within it, but yeah, like I'll show you. So for example, like, okay, so we need a function. First we'll just say function generate sub account ID. Okay, so this what happens is the sub account is basically generated from your address and the nouns. Okay, so the thing is, like, the format is pretty simple: 40 characters, 40 hex characters of the address, and the 24 hex characters of the nouns. So it just clubs it together, and that's how the a sub account ID is created. So the thing is, we need a way to pack it together, like the address part and the nonce part, and then we need to convert it to bytes. Like, it will be, sorry, from bytes to hex. Okay, bytes to hex string. So we need both of those things. So I'll just go ahead and create function ID. Like, we can do it in a single function, but it's always better to actually have helper functions and stuff. I'll just put it like that. Sorry. I'll just put it as helper functions, so that helper functions. Okay. So yeah. So we need the address, and you need the nouns, and it's going to be internal pure returns and string and memory. Right. So yeah. Uh, Right. So yeah, so we are going to return a string, like, which is going to be our nonce ID. So it's pretty simple. What we need to do, we'll just say bytes memory combined, meaning we are combining a couple of things: ABI dot encode packed, and we'll just say address and the nonce. Right. So yeah, so this is how you create the whole thing. Now before we return it, we need to convert it into a string, because it's like bytes, right? So we need to convert it into a string. So what we will do is we'll set up a function. We'll just say function bytes to hex string. So we'll just say bytes memory bytes and internal pure returns and string memory. And so bytes memory. So okay, So here, yeah. So this function, what it does is it will take all the uh, like the value that we have given, and it will just return like the like we said, the hex string. Uh, just give me a second. Okay, so that is the general idea. So we will pass this whole bytes thing that we, that we have from our generate sub account ID, and we'll pass it to this function, and it will just convert it. So, right, what it does is it takes the sequence of bytes and it will just convert it into a readable hex string, right? And the thing is, like, what it like. I mean, when you go into the technicality. Like the thing that it does is like it will take each of the bytes and it will basically convert it into a 2 hex character. Like I think it's from 0 to 9 and A to F. Okay, so these are the 2 hex characters that can be represented. So it will just convert each of them into these 2 hex characters. For example, like I'll show you, like it will take each of the bytes and it will just convert it into a 2 hex character. I think it's represented from 0 to 9 and A to F. Like you don't know, you need to know the technicalities, but it's like for those who are curious, I was just saying. So the thing is, what we have to do is, so in bytes memory, we have to provide the alphabets, or let me just check it. Okay. So I guess it's 2, 3, 4, 5, 6, 7, 8, 9, and yeah, till yes, A, B, C. Yeah. Okay. So it will be every bytes will be represented using these two two hex characters. Okay. And what we are going to say is bytes memory string equals new bytes, and we'll just take the length of our parameter bytes and outline, and we'll just do not a plus. Where is a yeah. Okay. So yeah. Oh, wait. Sorry. Okay. So this happens, and what we are going to do is for we'll just put for loop you went to 56 I equals 0, I less than bytes dot length, and I plus plus. Oh, the kind of typos that I make. Sorry. Yeah. So we'll just say str I 2 because it's like 2 bits, right? So equals alphabet, I mean 2 hex. So you went 8 and bytes I and 4, right? So yeah, so this is 1, and we'll just say str I into 2 plus 1, right? So the very next character, right? So it's going to be alphabet, sorry, you and 8 bytes I and 0f. What is 0f? Okay. Okay. So this basically does what I just told you guys. Like it will just represent each of them using a 2 hex character, and we'll just say return string of str. So yeah. So this is what we're going to use, and so we have the combined stuff here, and we just need to return this. So we'll just say return bytes to string and no, combined. So yeah, so this will return the string. So undeclared. Okay. So yeah, so now we have the helper functions. We'll just put it like a bit down, like since it's helper functions. Okay. So then what we are going to do is in our constructor we are going to use that to create our uh, you know uh, sub account ID. So we're going to say sub account ID equals generate and yeah. So address is going to be the address of the contract, and nonce is basically going to be the sub account nonce. So sub account nonce, right? So yeah, so this is how you set it. It's pretty simple. I mean, just a bit of conversion here and there. Nothing complex about it. You're just getting the packing the address and the nonce together, and then you're just converting like each byte into a two hex representation, which is like these things, and basically returning it as a string. So that's basically what you're doing. So this gets you your account ID. Now the first nouns, like the nouns that we're going to use, is the default one, which is one. So yeah, you can but use any of the nouns to create any number of like sub accounts, which is fine. So yeah, I mean this is the general stuff. Okay, so we have a constructor set. We have the functions for this thing. Now we can just start with a basic get function to get the sub account. So we'll just say get sub account ID, and we'll just say public view returns string memory, right? Okay, and we'll just say return sub account. Okay, so yeah, so this is our first function. So the next function is how we will place the limit order, right? So for placing the spot limit order, we need to know the market ID, we need to know the price, we need to know the quantity, and we need to know whether it is a buy or a like these things that we are given. It's a buy or a sell, right? So yeah, let's just go ahead and create the function. Function place spot limit order string call data market ID, right? So yeah, uint 256 price, or maybe we can just give it because otherwise it will be like really long. So price uint 256 quantity and bool, which is going to be this buy. Okay, it's is buy or sell, right? So yeah, so these things are there, and of course like there are a couple of extra stuff that we need to add, like whether the function is external, right? And it should be only owner, and there should be a valid sorry valid amount of quantity. What is that? Quantity, and of course a valid amount of price. Meaning it shouldn't be zero, right? And of course it returns string memory order hash. So it returns the order hash too, which can be useful, right? So we'll just say require. So we need the market ID to be valid, right? So we'll just say market ID dot length should be greater than zero, which means there should be a proper market ID, and we'll just say market ID. Okay, right. So next we'll just say I exchange dot spot order. Sorry. So what we are doing is like we are trying to use this. There is a spot order structure. derivatives. Just check spot order. Yeah, spot order, spot order. So there is a yeah. So this is the structure that we need to fill up in order to place the spot order. So we are just accessing it in our simple trade bot. So we'll just say I exchange module dot spot order and the memory, since it's memory order equals I exchange module dot spot order spot order, and we'll just say market ID. Like we have to make sure that we are basically providing the same thing as here. You can see the market ID, like sub account ID. So all those should be in the same. Like there shouldn't be any typos, right? So market ID sub. Okay, sub account ID. We I'll just go. Wait. Sub account ID fee So if you recipient, we are going to put it as blank, so they will just fill it with the default. Uh, okay. Then price is going to be price. What else? Quantity is going to be quantity. CID is going to be CID. I mean, CID is going to be empty string. Now order type. So order type, what we're going to do is we're going to say if it is buy, right? I mean, if it is true, we'll just say order type and buy, right? Else order type sell, right? So this is basically it, and we'll just put a trigger price. I mean, we don't need this exactly, but we just, yeah, since it requires it, so we'll just put a zero there. So, yeah, so this is basically our spot order. Now we need to create, using the, exchange instance of the contract, we need to just create a spot order. So, what we are going to do is we'll just say try exchange dot create spot limit order. You can see that, right? And yeah, so the sender is basically address dot this, and order is order. Yeah, I mean we've already given it. And we'll remove this, and we'll just say return. So it needs to return something. I exchange module dot create spot limit response, limit order response, right? Memory response. So this is what it's going to return. So, oh, sorry, not return, returns. And within it, we'll just emit our event, right? So we'll just say spot order placed. And yeah, so market ID is by price, quantity, order hash. Okay. So for order hash, we'll just say response dot order hash. Okay. And for timestamp, we will just say block dot timestamp. So yeah, so this is basically you know this whole thing where we're going to emit like once this whole thing is returned, we'll just emit our um, you know event, and we'll just say return. Oh wait, and within it we'll just say return respond. Sorry, response dot order hash, right? So yeah, so this is basically what we are doing. So we are trying to get the limit order placed, and using the exchange dot limit order function, and we are expecting it to return this response, and we emit the event, and we basically from the response just get the order hash, right? So yeah, so that is the first part. Now just provide a catch. Of course there might be an error, so we'll just say string memory reason, which is basically the message, right? So revert, and we will say string avi dot encode packed, and we'll just say order meant failed, or we can say catch bytes memory order placement failed with none error. Here we can add the whole thing. Yes, why not? Reason. Okay. Yeah. So that is all right. So I guess that's it. I mean, we have. Oh, sorry. Okay. So yeah, so we have basically set up our order function, which is pretty much straightforward. Like we just use the whole thing. I mean, we just use our, uh, you know, the contract instance to call the function, provide the details, and then it will do its thing, right? You don't need to, you don't have to write like complex logic or anything. So similarly, we are going to write our cancel function, which will, as you guys know, cancel the order. So we'll just say function cancel spot order, and we need a couple of things, which is string call data market id and string call data order hash. So these are the two things that we need, and of course it's going to be external, it's going to be only owner, and it's going to return success. That means we have successfully cancelled our order, right? And it also requires a couple of stuff, like one is the same thing. We need to check if the market id is proper, invalid market id. Else we also need to check, oh, sorry, we also need to check if the order hash is proper, right? And we'll just say invalid order hash. Okay, so yeah, so those are the two things, and then just like last time, we are going to do a try catch. So try exchange dot cancel spot order, right? And so the address is going to be this address, the market ID, basically the market ID that we just market ID, right? Market ID, yeah. Sub account is, I guess, sub account itself. I mean, make sure that we are, yeah, it's ID, sub account ID. Okay. Order hash is basically order hash itself with an underscore, and CID, yeah, we don't have. Okay. So yeah, so this is basically what we are going to try, like market ID. Just make sure that the cap and everything is proper. Otherwise, it's going to. I mean, it's a very nasty error if you know, the cap is like there is a casing error. You have to look for it a lot. So yeah, returns. What does it return? Bool result, right? And we'll just say Okay. Yeah. So we will return the result. Yeah. Yeah. Return result. Okay. So yeah. So this is basically the whole thing. I mean, it's nothing complex. Again, we'll just call this function and return the result, uh, right? And we can also put some errors. I mean, basically the same thing. We'll just copy paste it. Just paste it here and order cancellation, and we'll just say the same thing here. Okay. Yeah, so this is basically it in terms of canceling the order. Now, okay, so these are the two major functions, like we need to place an order and cancel the order. Now there is one more thing, like I told you, like once we have the whole thing up and running, like the contract is there, we fund the contract, we also need to deposit us the amount, uh, uh, you know we also need to deposit the amount to our sub account. So that's what we're going to do now. So we'll just say function to exchange. So yeah, so this is the trade account. So we will just say string call data denom. So how much the denomination of the amount, and we will just say uint 256 amount. So yeah, so we need to put certain amount of a particular denomination. So again, it's going to be external. It's going to be only honor, and it needs to have like the validity. So we'll just say valid, not valid, valid amount. This is going to be amount, and it's return. It will return success, right? Yeah, I mean, tool success. Okay, so yeah, so this is basically the first part. I'm so sorry, I have a very dry throat. So yeah, so this is basically the thing. Like we need to deposit now. Let's just see how we are going to deposit the whole thing. So first, we need to make sure that we have the balance. So we are going to say if bytes. We're going to check the denom, and we are basically going to make sure that it's like we're going to hash it and make sure that sorry, we're going to hash it and we're going to make sure that it's bytes. Require address this dot balance greater than equal to amount, and we just say insufficient contract balance, right? So from our contract we are just giving it to the sub account. So we basically need to make sure that we have the proper amount of balance in our account. So that's the whole thing. Like inject, like we are just checking the denomination to see if it is injective, which is like the native token. And if we don't have the enough balance to fill the amount, then yeah, I mean, what's the point, right? So yeah, so then we are going to again do an exchange dot deposit. So this function, the sender is going to be address dot this. So this is again a function of the precompile. So sub account is basically sub account ID. Isn't that? I mean, I'm so sorry. Just give me a second. Yeah, it's just why is it not picking it up? I mean, I get scared when the autocomplete is not working. So yeah, denom is basically denom with an underscore, and amount is also amount with an underscore, right? So yeah, and then we'll just say returns bool result and return result. Right. So yeah, and then since it's try, we need to add a few catch, and yeah, it's basically the same thing. Just put the catch, and you can just say deposit failed, right? Deposit failed. Same here. Deposit failed. Okay. Yeah. So this is it. So yeah, we set up a function to deposit to our sub account. Now we can add a couple of other functions. For example, we can add a function called function sub account. Oh, sorry. Get sub account balance. Right. We just say string call data denote and external and view and returns. What does it return? UNT 256 away level balance, and there's also a total balance. Okay, so if we we can just get it because like I'll show you how to get it. There is also one more thing called UNT 256 total balance. Okay, so yeah, so to get this, it's pretty easy. You just have to do return exchange dot sub. Yeah, there you go. Sub account ID and D. Okay. Oh, oh, sorry, I reversed it. ID and D. Okay. So yeah, so there you go. That's your sub account. Then you can also have a function called get contract info, which is also external, which is also view, which is also, which also returns a couple of things like address of contract address, just in case somebody needs it. Then another address of owner, contract owner, another bool, which is like is paused or not. What else? String, memory, current, sub account, ID. ID. Oh, sorry. ID. Okay. So yeah. So this is there, and we'll just return address dot this owner trading past sub account ID. Okay. So yeah, that's also there, and we'll just put that. Okay. What else? What else? Then oh yeah, we'll just have our receive function, and it's just external payable. Nothing going on there. Just external payable, and a fallback function, of course. Fallback because like there can be times when people can have typos and type something else for calling a function, and yeah, people make mistakes, so it's nice to have a fallback. Invalid function call. Right. I guess that's pretty much it. We have all the functions. Deposit. Yeah. I guess that's basically our trading bot. So you can place orders and cancel orders, right? You can just fund it, and you can just based on your instructions, the bot will place and fund. Place and deposit. Sorry, place and cancel orders, right? So let's just go ahead and compile this and see if there is any errors. No, it's good. So yeah, our contract is basically done. So now let's just go ahead and write the scripts to deploy and interact with it. Right? Yeah, let's go. Let's see if our contract works. All right. So Yeah, now that we have our contract set, let's just go ahead and create a few scripts to, deploy and interact and place our orders and stuff. Right? So, yeah, let's start with the first one, which is deploy. So, let me just create deploy.js. And yeah, I think let me just check something. Ah, yes. Okay. Cool. Cool, cool, cool. Okay. So, we'll just say async function main, no parameters, right? So we are going to say, yeah, we're going to deploy contracts. So we need to get the deployer address, deploy, deployer, and await ethers dot get signers, not signer, signers. Make sure it's yeah, and you can say console dot log. Yeah, you can say deployer address and deploy.address, right? So yeah, I mean, okay, so now the thing is, okay, so we have the deployer address. Yeah, I think I'll show you how to run the script after we have written our first script. Okay, so yeah, then we can, okay, just like last time, we need to check the balance, like just like how we did in the contract. Await ethers dot provider dot get balance deployer dot address. So yeah, we are just getting the address, like the deployer's balance. We'll just say deploy, yeah, balance. I mean, these are like information so that we can debug better in case of any error. It's not a necessity. You can just type in whatever you want. Like you can just quickly go on to the whole, uh, you know, uh, contract stuff, and you don't need to put all these things. But like I said, it's much easier if you like in case there are some errors and stuff. It's much easier to debug if you have a lot of console logs. So sub account nonce nonce equals one, right? What else? So yeah, let's just go ahead and say const simple trading bot equals weight ethers dot get contract factory simple trading bot. Okay, and const bot equal await simple trading bot dot deploy. And when we deploy, we need to provide the sub account balance, because I mean sub account nonce, because that's there in the that's there in our constructor, right? We take that parameter. So it's pretty simple. You get the instance of the contract and you just deploy it, and the deployed instance is now in the bot, right? So we can just wait for deployment. We can just say wait bot dot wait for deployment. And so then once it is deployed, we can basically get the address. We can say const contract address equals await bot dot get address, right? Pretty simple. So we can console dot log that, console dot log. We'll just say contract address equals contract address. Yes. So yeah, and like if you need more info, I mean, you can do it if you want to, but yeah, I guess you can get the sub account ID, or you can just get everything. It's fine. Const address owner, because we have the function get contract info, so is post and sub account id, right? So all these things we'll just say await bot dot get contract info, right? So yeah, so this is basically this. Now we can just console log these things. Just say console dot log owner equals owner. I mean, we already have the address. That's why I'm not going for the address. Okay. Slash in. What else? Yeah, just put the sub account ID equals yeah, sub account. Okay, maybe a slash. Yeah, you can format it however you like. But yeah, so then we just call the main function main and dot then, and within the dot then we'll just say uh, process dot exit zero, and of course in case there is any error, we'll just catch that error so that we know what the error is, and we'll just display it. Dot log error. Okay, so yeah, I mean this is basically it, and we'll also exit the function. Process exit exit zero or exit one. Yeah. Yeah, so this is basically it. This is a basic contract. I mean, it's like, I don't know, 5 lines, 10 lines. But yeah, let's just go ahead and run this. So to run this, just type in npx hardhat run scripts slash deploy.js, right? So yeah, slash deploy.js and network. Yeah, of course. You have to give the network. Um, and the network, like make sure that you give the proper name, which is injective testnet. So place it here, and yeah. Now let's see if there are any errors. Let's go. Ah, okay. Get contract info is not a function. Okay. Our contract is deployed, but we have a small issue, which is we just have to check if there is any name issue. Oh wow, typos. Yeah, let's just try that again. So if you just deploy it, it will automatically compile it. You can see all the changes will be compiled. And balance. Yes, yes, there you go. So all the things are there, right? I mean, the deployer address, balance, contract address. We have everything, so that's pretty good. Now we'll just store it somewhere so that we can use it a lot of places. We'll just say deployment, and we'll just say contract address. Okay, and I guess we also can copy the sub account ID. I think it's already created. I mean, it's deterministic, so it's fine. Sub account. But yeah, let's just store it. Okay, cool. So yeah, our first one is successful. Now what we need is we need to actually fund the you know contract right from our account. Since it's our bot, we need to fund it. So let's just create a fund.js. Fund.js. Right, so again it's going to be an async function. Async function, we'll call it main, no parameters, right? We can, yeah, we'll just keep the contract address, it's fine. Also const contract address, or we can just put it like, since it's a const contract address equals, so this is the contract address, right? Yeah, and it's pretty much the same thing. Uh, like a lot of it is pretty same, so I'll just copy it from deployer. I think um, till this part, it's pretty much the same. Um I don't think we need the balance, but yeah, I mean, rest is pretty much the same. I'll just copy this. Uh, you don't need to display the balance all the time, I guess. Deploy dot address balance. Yeah, I mean, we can format it. It's fine. I mean, ethers. Oh wait. Okay. Ethers dot. How do we format it? Format ether. Oh yeah, of course. So yeah. So we don't need the nouns thing right now because we already used it. So yeah, we get the deployer address, we get the balance. We'll just call it sender balance. We don't sender address, right? Because we are the senders, and so we have the simple trading bot. So again, like last time, const bot. Now we don't have to deploy it; we just have to attach it. So we'll just say simple trading bot. Now attach the contract address. Contract, right? So we have since we have already deployed it, we don't have to do a redeployment. We just have to attach it to the instance so that it knows, right? So we can say const. You can directly just fund the thing if you want. You can say a balance after and a balance before thing, which is also fine. You can just set the balance, take the balance before the send and after the send to make sure that everything is perfect. Or we can just go ahead and try this out. So what we can do is first, fund amount in waves. So what we're going to do, we are going to send one injective token, right? So ethers dot parse ether, and I'm just going to say 1.0. So this is the amount that we're going to send. So we can console log that. Console.log um, sender funding fund amount contract. Okay, whatever. You know. So yeah. So if it's a if the fund amount in case is greater than or equal to the balance, we have to warn the guy. We'll just say throw new error, right? I mean error, right? And we'll just say, dude, it's insufficient balance. Go get some tokens. You need more tokens. Okay. So yeah, to cover. Oh, we can just say cover. Oh wait, that's actually pretty neat. We'll just say insufficient balance. You need more tokens to cover. How much is it? Um, fund amount we range. Or we can just say it's just one. Okay, we'll just put it like 1.1 inject. One inject. Okay, yeah. So we're just saying that since that is the fund amount, it's pretty just a console log again. Uh, just so we can debug better, we can say sending one contract. Equals transaction equals await deployer. Sorry, send transaction and to contract address value fund amount. Okay. So yeah, this is basically the send transaction. We can just say await x dot wait, right, and we can get the balance. We can just say what is the get balance? We can just say contract balance, right? So we can get the contract address, and we can just say console.log new contract balance, which is going to be contract balance. So yeah, so yeah, now let's see if the funding works. I mean, make sure. Okay, so to do this, make sure that in your own wallet, make sure that you have enough. Uh, you know, yeah, you have enough injective tokens. I have around nine inject. How much do I have? I think this is the main account. Okay. So how much tokens do I have? I have six injectors, which is fine, right? So yeah, I'm pretty loaded, so it's good. So let's just try out scripts instead of deploy. I'm just going to say fund, right? So yeah, I mean that's the only change that you need, and let's see what happens. Of course, I mean, mhm, you need to copy this. Sorry. Yeah, let's do that again. Sender address. Simple trading bot is not a function. So what happened there? Simple trading bot is not a function. That's true. Oh, oh, wow. Attach. Sorry. Let's go again. Sender address. Uh, did I use some other? Okay, wait. Okay, I might be using a. Oh, I'm using a different account. Oh, sorry. Let me just okay quickly get the. Wait. I'm so sorry. Let me just switch. So what going to do is switch the private key. You don't have to do it. Uh, so I might just have to redeploy it so that the owner is. Let me just change the private key. So sorry. Yeah, I mean the private key was different. So yeah. So yeah, I mean, so the problem was I was using a different account with insufficient balance. So I let me just deploy it first so that I mean I need the you know contract address. Now make sure that the contract address is copied, saved, and where else do we need to save it? In the fund because we don't want to fund the wrong contract. Okay. Now let's just go ahead and fund this contract. Let's see what happens. Okay. Yes. Now this is our address. Ah. Okay. See. Now we had like a six, and I'm pretty sure I'm down to five. So yeah, that's basically it. Like I was using the wrong account. That's why the balance error came in. But yeah, it's pretty easy. Like just swap out the private key with the private key of the account that has balance, right? So yeah, that is done. What else? Now we need to deposit. Okay, so the next part is like we need to deposit the whole thing. Like I told you, we funded the account. Now we need to move the fund to the sub account, right? So for that, we need. Yeah, let's just go ahead and create a new script, deposit.js. Okay, so Yeah, it's I'll just say const. So I'll just say const contract address is going to be the same thing. Why did I? Okay. So and I will just say deposit amount const deposit amount so that we know what we're doing. So see since we have uh, like one injective token, we'll just send point 0.5, right? And const denom. Now this has to be injective because you remember the check that we did in the contract, right? So it has to be injective and then async function name ABB, yeah. So again, it's pretty much the same thing as last time. We need the deployer like with funds. Okay, so we are doing this. We just copy it. We just modify it. Okay. So deployer get signer. It's like the deployer address. We can also put the contract address here. We say contract address and we just say contract address. Okay. So yeah. So contract address and we don't need the balance every time. I mean, okay. So simple trading bot, get the simple trading bot, attach it to the contract address. All that is pretty much the same. Now we have to, I mean, this is okay. Like this is a check that we have. We already have a. Um, I think like if you look at it, let me just check. I was thinking of creating a. So deposit. What is deposit? Yeah, it's only honor, so it's fine. Yeah, I was thinking of creating an extra check here to check if the owner is calling the function, but we don't need it because we already have this whole thing. We can check the, you know, we can basically check uh, the contract balance if you want. Contract, const, and we also have that in fund, right? Yeah, we can do the same thing here. I mean, there is not much coding. It's just copy paste. I mean, scripting in this is something that I absolutely love about TypeScript. Hardhat. Like the scripting is pretty easy. Okay, so then we can have const deposit amount in way, and we can say users dot parse ether dot deposit amount. Yeah, so that we get it in way, and yeah, we can do the same check. Like if we already have it. So yeah, so we'll just say contract balance and deposit to cover deposit. Right, so we don't have the amount. Okay, so that is also there, and then we can just go ahead and get the sub account. So we need the sub account. So we're going to say const sub sub account ID equals. Now you can copy that, or you can even use the bot dot get sub account ID. Okay, so yeah, I mean, just make sure that you this is the right thing. I mean, I don't want another situation. Yeah, get sub account ID. Just- Yeah, or you can paste it. It's fine. I'm just using it so that you know how to call each function. That's it. Yeah. So you can also console log it. Console.log sub account ID equals subcon ID. Okay, right. So yeah, okay. So this is pretty much it. Yeah. So we have the sub account ID now. We can what we can do is we can get some exchange balance. Maybe like we can actually try and get the sub account balance. Um, I think. Wait. Did we have set a function for it? I don't think we have it. Ah, okay. So we can call this function and get the sub account balance. Okay, that's cool. So we can just say try and within the const available before and total before, and you can say equals wait for get, just copy that thing. Get sub account balance, and we just have to give the which is I think we have provided the below. Yeah, yeah. So yeah, so this will get us the sub account balance. So we can just say console.log and available, which is going to be heaters dot format heater and available before and Dino, right? And console.log total. Dino. All right. So yeah. So just it's again. Dash E, dash E, and we can say console.log error get sub. Okay, we got message maybe. Yeah. Okay. So yeah. So next we need to deposit to exchange. It's pretty easy. I mean, um, yeah. I mean, you can just. So what you have to do is just do a const transaction which is equals await await bot dot again, let me just copy it. Deposit to exchange. I really don't want mix up with the case, like the casing and redo and recheck the whole thing. So we just say denom and deposit amount wait. Right? Okay. So this will do the whole thing. We just have to wait const receipt equals await transaction dot wait. You can put the hash if you want. And just say console dot log transaction hash equals uh, okay. So yeah, and yeah, so we have the receipt. We can get a few information out of it. We can even say console.log uh, And we can even do the same thing here. I mean, it's fine. Just to check if everything is proper, right? And yeah, maybe even the balance contract balance thing, just to check if that is also proper. So we'll just say after, yeah, okay. And of course, we need to do one more thing, which is this. Copy this, cross it, and paste it here. Okay. So yeah, let's see if we have made any mistakes. So again, it's pretty much the same thing. We just have to deposit, right? So yeah, let's see what happens. New balance, total available, of course. Our sub account doesn't have it, and there you go. There you go. You can see it's confirmed, and then our sub account balance is now zero point 0.5 injected, right? So yeah, I mean we have successfully deposited the amount to our injective, sub account, which is pretty cool. You can see the difference, right? So yeah, I mean next, I guess we move on to the other one, which is place order. Now this one might be a bit big in terms of what we have to do. I'll just say place order.js. Okay, so yeah, I mean here we have to. I mean a couple of things are pretty much the same. Like we need the contract address. We'll just copy this. We'll just paste it somewhere here. So apart from that, we also need the market ID. You remember that market ID, which is going to be, yeah, we have to go to the uh, you know, Injective Explorer for that. So I'll just go here. Yeah, so Injective USDT, just copy this and paste it here. And then we can also have things like const order, like the price, which is equal to 25, 25.5. Again, const order quantity, which is equal to, I don't know, 0.01, right? So yeah, so this, like the order price is like the price in USDT per injective, and the quantity is basically quantity in injective. Okay, so yeah, and we have to just check if it is a buy or a sell. So const, is it a buy? No, we're going to sell it. Right, we are going to sell our injective for something. Right, so false. Okay, so yeah, we want the price uh, in injective per USD is 25.5, and we are willing to send for the we are willing to send like 0.01 injective. So let's see how many USDT we get. Right? So yeah, it's a cell, and let's just go and assign function main operands. Yes. Okay, so yeah, again we need to repeat a couple of stuff. I'll just I'll just copy it from deposit. We can have all the way till, yeah, we can have these two. So console.log everything, and on spot. Okay, so this is there. So we can check if the bot is paused. So we can just say const is paused equals await bot dot get. It's trading post. Yeah. So yeah. All right. So yeah, trading post. So if not this post, I'm sorry. If this post, raw, new, error, we're just going to say trade, trading is post. Okay. So again, we can also get the sub account ID. I'll just copy paste it because I'm lazy like that. Uh, sorry. I mean, after this. Okay. And yeah, so the next part is what we need to do is we basically need to set something like the check exchange balance. Like, I think if you go here, you can see the USDT, right? So this is basically, we are going to sell like the, you can see the denominator, right? So similarly, we are going to set up something called like if it is buy or sell based on that we'll set up the denominator, I mean denomination. So if it is buying, like it should be the USDT. If it is not buying, then it should be injected, right? So that is the whole thing. Like I'll paste it and I'll show you. Yeah, just give me a second. Let me just verify something. Okay. Yeah, just get the. Sorry. So just get the denom. You can see the denom, right? So this is basically the denomination. Oh wait, I might have just messed it up. Wait. Oh, did I? Oh, oh wow. I might have messed it up. I mean, if it's market info, wait. Wow. I think yeah. Just make sure that you are in testnet. I think I might have just messed that part up. So we might have to. Where is injecting USDT? Oh, okay. Okay, so that is a market ID. Oh, wow. Make sure you put that market ID. Uh, there's a market ID. So this is different. That's in mainnet. And even this one, I think I copied it from mainnet. So let me just get the testnet one. Oh, okay. So this is the testnet. Okay. So we are saying if it is a buy, then this is going to be the denomination, which is USDT. Else, if it's a sell, yeah, you can see USDT for buy, injective for sell, right? So that is basically how we have set it up. Again, you can get it from the like Explorer itself. Just make sure that you're on testnet. Otherwise, it's the whole of this will be for nothing. You can get the market ID from like you can get the pair and get the market ID right here, and just click on this, and you will get the denominations. And yeah, just to check the market ID, FE, right? Okay. Yeah, so that part is also done. So next, we need to basically get the sub account balance. So again, it's basically the same thing that we did here. We just copy this and we'll just paste it here. Just paste it here. Okay, better. Okay, so this part is pretty much the same, denom and everything. Yeah, I mean, yeah, of course, it's here. So this part is pretty much the same. We are console out logging everything. Now we have to add one more stuff, which is if not this pi, right? We're going to say const order quantity way. So we just have to get the quantity in way, and we are going to say ethers pass ether and order quantity, right? And if order quantity greater than available, I mean, yeah, available before, so we can just put it as available and total. So it's easier, right? Available and total. Okay, we'll just say available. Okay. So yeah, so if the quantity is greater than available, there is no way to actually do this. So we'll just say, okay, so if this is there, we'll say throw new error. We don't have the like, so this checks the balance, right? So we don't have enough balance, so we'll just say insufficient balance, right? To cover the quantity, we'll just say uh, um, yeah. Okay, so yeah, I mean that's basically it. Like we are just saying that we need to set the whole thing properly. Like we need the proper balance and everything. And yeah, so once you have that, let's just go ahead and convert the price and everything to. Sorry, let's just go ahead and convert the price and everything to way. So I'll just say const price way equals meters dot parse ether order price const quantity way equals ether dot parse ether order quantity, right? And const transaction equals await bot dot, let me just paste it, which is place, yeah, place bot order, right? And yeah, so market ID, price in way, quantity in way, and is by. Okay, so yeah, so this is it, and we can console.log transaction hash, which is equals transaction hash, right? And we can get the receipt like just like how we did last time. Again, I'm very lazy with these kind of things, so I'll just do this instead, right? And yeah, I guess so. I mean, there is one more thing that we can do. So okay, I'll just, so this is a script for actually passing the event. So what? Okay, so here what we are doing is there is an event, right? So from the receipt, what we are doing is we are in the logs. We check the logs and we pass the log, and basically what we are looking for is the event. Like the past, like you remember how we put the event, right? Like past event, log event. So we are just looking for that, and like once if we find that event, like if the past name is that event, we will just return it. Okay, we will return the event. right? So if we have something in the event, what we are going to do is we are going to using the interface, we are going to pass the whole order placed event so that we can get its parameters. And one of the parameters is obviously the order hash, right? So we will just console.log that order hash. You can see that, right? So yeah, I mean, this is how we are going to, if we get the order hash, that means the order is placed, right? So yeah, so this is how you pass the event and basically get the details out of the event. Yeah, now let's just go and run this whole thing, copy this and run this. Okay, so yeah, we can try and run this. Let's see what happens. So this is called place order.js, right? So yeah, what can possibly go wrong? Let's see. Contract address, okay, available. Transaction hash, okay. There you go. The order is placed. You can see that, right? You can see that the order is placed. So let's see here. Let's go here. Let's see if we can see something. Uh, I don't know where we can place it. Mm, okay, markets, search markets. Let's see. Okay, maybe there is a way to see it, but yeah, I can't do it. Takes a consistent spot. Maybe market info. Okay, it's not a transaction hash. Maybe yeah, but the thing is, the order is placed. I'm pretty sure you'll be able to find it somewhere since it's spot. Maybe it might just take some time. Maybe it's this it. No, I mean, yeah, it might just take low volume markets. Okay, but yeah, anyway, so the thing is, we actually got our order placed. Now, so it's this is how you write the scripts. Now, what I'm going to do is like, so I will obviously put the solution in the GitHub, but I want you guys to try and write the script for canceling the order, right? So you have the order hash, and if you look at the cancel function, it just takes a couple of stuff. What is the cancel function? Yeah, it just takes the market ID and it just takes the order hash. That's it. And you just have to call the functions like we did, with all these things. So it's pretty simple. So try and write the cancel function, and so that we have our entire script. But yeah, I mean, right now we are actually we have actually created a simple trading bot that is running on top of the injective testnet, and it's trading, right? It's actually trading. Like we can put funds there, deposit it to sub accounts, and it does the trade for us, right? So it's pretty cool. And you guys, like if you go to the docs, like the injective docs and everything, you there are a lot of cool like other cool stuff that you can do with this thing. You can just try it out, all the, yeah, I mean, this is basically, sorry, it's like injective dots. Yeah, if you go to the docs, like there are a lot of other precompiles, lot of other functions that we haven't discussed, but do check it out and see how you can create something cool with it. And as a small assignment, try and actually write the script for canceling the order, right? It's pretty simple. We have done the same thing over and over and over again, so it's going to be fun. It's quick little challenge just to see how you guys fared so far. But yeah, I guess that's it. We have successfully deployed our bot and placed an order, which is cool. So go ahead, build something cool with it, and see you around.